Our next speaker is Kevin Hoskins, and he's the Vice President of Telecom and Information Systems for the Marine Spill Response Corporation, or MSRC, which is the largest dedicated oil spill and emergency response organization in the nation. And he has spent the last 27 years building and refining MSRC's telecom and information systems infrastructure, and more recently was appointed the program manager of MSRC's surveillance and remote sensing services. So without further ado, Kevin.
All right. Well, thank you very much for the opportunity to present to the group today. And this is kind of, like Monica said, a little perfect segue, because I'm going to talk about the practical application of some of the science that the speakers spoke about this morning. Is everyone familiar with MSRC, Marine Spill Response Corporation? I don't want to go into it too much, but again, like the bio said, it's the largest dedicated oil spill and emergency response organization in the United States. So I encourage you to check out our website. It has a lot of details on our capabilities. And so with that, we'll get started. We're briefly going to talk about some surveillance goals and some of the technical challenges on meeting those goals. And then I'll give you an overview of what MSRC has in our inventory as far as surveillance technologies or platforms. And then I'll go into a little bit more detail on a system that we call TRACS, or the Tactical Response Airborne Classification System. That's a mouthful. And that's and also an Aerostat that we use. And then I'll close the presentation with some opportunities for this technology beyond oil spills. What are surveillance goals for our effective oil recovery? I think first is timely tactical decisions, and I can't emphasize enough timely. During Macondo, there were several times where we would get overflight information, but the information was so stale that by the time we got our assets to that location, the oil had moved, or it was a false target. So timely tactical decisions is very important. Find and stay with the oil, and then reposition our assets as it moves. Another goal is to target recoverable oil. Again, like I said earlier, we were sent to chase after false targets or non-recoverable oil, or oil that had moved because the information we got was 4 or 5 hours old. And then, again, avoid false targets. We need complete information. Multiple surveillance technologies complement each other and give us a really good overall picture. And finally, we want to be able to expand the operating window beyond daylight, and also when weather conditions aren't optimal. All right, so what are some of the challenges to these goals? Oil water footprints fingerprints are complex, and I think Oscar's slide there that depicted the various types of oil and how the sensors discern that oil was very interesting to me. There are a variety of types and thicknesses. No single sensor provides all the answers, right? Some can only provide detection. They may not be able to distinguish recoverable versus sheen. That's another very important piece of information for us. We need to have actionable oil. So, and again, false targets. And then finally, environmental limitations, clouds or humidity can impact the quality of thermal infrared imagery. And then obviously when you're in low light, the optical sensors become much less effective. And then of course the FAA restrictions that may come into play. Can we even fly a drone? Can we fly our aircraft? Are there flight restrictions? All that kind of thing that we need to vet out and could prevent us from meeting our goals. All right, so with that, I'll walk you through the technologies that we currently utilize. First, again, we have taken a very tactical approach to this. Our interest is in identifying the actionable oil, and then the ability to direct our on-water assets to that location. So the first thing I'll talk about is our visual observation report. That's an application that we built for iOS devices. It runs on your iPhone or your iPad, and it utilizes the internal camera and GPS. So basically, we can get in an aircraft, go out there and plot the spill, build a workbox, characterize the oil, take pictures, make notes, and then at the end of the day, this all gets exported into a PDF document and emailed as soon as we can get back into the cellular coverage. So, very useful tool. I remember the days of the folks going out with their computer and their phones and the cameras and trying to put all this information together in the back of an airplane. Now it's just we take our iPad and off we go. Next is the aerial platform, the TRAX. Again, we love those acronyms. It's multispectral and thermal infrared technology. Again, this is an exclusive agreement we have with a company called Ocean Imaging. I know there's a lot of folks in the room that know Jan and Mark, but it's their equipment. They put this stuff together basically for us. It's designed for non-technical people to operate. Aerostat, we have 3 of those systems as well. They have HD and thermal infrared technology. And again, not quite as high a height of eye, but they have a long hang time, and they can be up in the air 24 hours. Next is the vessel-mounted systems. We have 14 oil spill response vessels, 210 foot. They were specifically designed for oil spills to clean up oil. And so we have X-band and FLIR technology mounted on all of those vessels. Again, a little bit lower height of eye. The antennas are about 75 feet. Detection up to 2 miles, and then they can start to discern thick or actionable oil from sheen at about 1,000 feet. So, and then we have some portable FLIRs for again, more acronyms, platform supply vessels that we use as skimming vessels. We can actually put skimming platforms on these supply boats and then give them some FLIR capability to help them identify the thickest part of the slick. And drones or UAVs. We don't own any. We do have contracts with several providers that do this routinely, and certainly Oscar would be one of the guys that I'd want to call if we had a need. So, but there's a lot of versatility, a lot of sensors coming out that improve their applications. So let's talk a little bit more in depth about the Tactical Response Airborne Classification System. I'm going to show you a picture of the original. This was when we first established our relationship with Ocean Imaging, and this was their proof of concept, and we needed to come up with a solution that we could streamline the installation process and make this basically fit in any aircraft that had a downward-looking observation port. So we did a little re-engineering, and this is the system as it exists today. And very quickly, you can see what is labeled as a positioner there. That's the red box. That's basically a GPS on steroids. That corrects for the speed, pitch, roll, and yaw of the aircraft. And the operators basically sit in the aircraft with a laptop that's got a remote desktop connection to the main computer, and they control the 2 cameras. They can view what the cameras are seeing, and they can control what they want to record. So again, thermal, infrared, and multispectral cameras. And the computer that you see there is actually doing all the processing. So across you can see some of the imagery that this will produce. And I'll speak real quick to the top 3 pictures there. The first is just what your eyes would see. It's a photo. And then the second is the multispectral image. And then the third is the thermal image. And to me, the thermal image is the most interesting, because the bright white is actually emulsified oil, and that's the thickest oil. And that's the hottest, right? It's because this is IR and white is hot. And the black is still actionable oil, but in this particular image is cooler than the surrounding water. And but it gives you a really good snapshot of what's out there and where you should focus your attentions. So Again, we want to differentiate between thick and thin oil, recoverable versus sheen. We can cover a large area, and just to give you kind of an idea of what that means, at an altitude of 5,000 feet, the image swath is 5,600 feet. And the pixel resolution for multispectral is about 3.47 feet, and the thermal pixel is 5.5 feet. So again, pretty good resolution. Now remember that when we're actually flying and we want to image a large area, there will be some overlap. So we don't have spaces when we try to stitch it all together. All right, so our deployment strategy is we don't have dedicated aircraft. They're very expensive. So what we've done is pre-identified aircraft, what we call aircraft of opportunity. They have to have a downward-looking observation port. They have to meet our safety standards. And we have several located around the country, Virginia, Louisiana, California, and Hawaii. And the system is operated by our personnel. We have a strike team made up of operational folks and some of my telecom gurus that understand all the science and the computers and how it all connects up. And we have about 16 people on this strike team, and it's an additional duty to these guys. And we train routinely on this equipment. 3 systems located in New Jersey, Louisiana, and the state of Washington. And some of the technology does have export restrictions on it, and because we are very interested in the ability to use this technology if there was a spill that went into Mexican waters or off the coast of Mexico, that we could use this. So we did get a what's called a tools of the trade exemption in order to use this technology there. And let me see. So the operator can do the images, and they can create a mosaic in the aircraft and send that mosaic real time down to one of our vessels, and then they can use that information right on the bridge and take a look at it. Like they say, a picture paints 1,000 words. And we can also send them a geotiff, which then they can actually import into their navigational system, and then they've got they can get their heading information and all that right out of that information. So pretty streamlined. And nighttime operations, of course, the thermal infrared isn't impacted by the lack of light. And we'll talk a little bit more about the thickness stratification maps that can be developed from this as well. And we do actually have one of these stratification maps from Training Evolution that we're going to do off the coast of California. And at the same time, as luck would have it, the Refugio spill happened. So we were able to take that opportunity and go out and image that spill. And this is the stratification thickness map that resulted from it. So this is the type of product that you can get from the images and from ocean imaging. Typically, this is a little more time consuming. There's a lot of data that you collect. We need to transfer that data out to ocean imaging in Colorado. It takes them about 4 to 6 hours to turn it around. Here's another example. This, I believe, is from the Macondo spill, of some more images that were done by Jan and Mark, and of course the colors depict the thickness. And if you have sequential overflights, you have the capability to also provide drift movements with estimated speed and direction. So this is all products that ocean imaging can put together from the raw data that we collect. All right, so that's about the tracks. Now we'll move into the Aerostat, give you some more details about that. I'll start out by, again, remember this has high def and thermal infrared capabilities. And I'll talk about the 2 pictures there, which I think are the best. They really tell the story as far as the capabilities and why we see this as so important. This is oil on water over in Norway. I think it's 2015. And the top picture, of course, shows just the optical or HD camera. And looking at that image, I think it's very difficult to determine where exactly you should focus your attention, where do you put your boom and skimmers, because it looks like just one huge slick, right? But as soon as you flip over to IR, which is the bottom picture, it becomes very defined and very certain where you should focus your attention, because the black there is the thickest or actionable oil. So that's the beauty of this system. You can flip back and forth, and because IR typically does not depict or sheen. So if you see it in IR, it's usually actionable. You can skim it. Medium range, we're capped at 500 feet that we can fly the balloon. Relatively low cost. Helium really is, it has a 12-hour hang time. It's battery operated, so every 12 hours bring it down, swap the battery, top it off with helium, and send it back up. FAA restrictions pretty much non-existent in uncontrolled airspace. The only additional requirement at night is that you have to light the tether and make sure that there's a strobe on top of the balloon. And again, we can track the oil. That's we put it on back of one of our OSRVs, and as the oil starts to move, this system will help them stay with it. We can deploy from a variety of platforms. Whether we've done some jobs where it was in the back of a pickup truck, and I'll show you, I'll talk about that in a case study here in a couple of minutes. So again, we want to direct resources to the thickest oil, day and nighttime operations, and we can also send this information pretty readily off the vessel to other command centers or so forth. Here's just a couple of pictures of a deployment we did a couple of years back in California. Again, we used the helo deck of one of our oil spill response vessels to deploy from. It's a perfect platform for that. Then you can see the right hand is just the balloon that's deployed. I think it's roughly about 350 feet there. So mandatory to have a cut down system for these balloons. So basically it's an RF link that we have a guy that's always watching the balloon, and if for some reason it gets off the tether, you activate the self-destruct button, and it burns a hole in the balloon, and the balloon kind of just comes down. So. All right, a couple of quick case studies real quick. The top one is one I think I was referring to, where we had a customer that had a tank farm on a river that was at flood stage, and they were really concerned about what might happen if the flood got into the tank farm, and what would happen to the tanks, especially at night, because it was very difficult for them to monitor it. So we were able to take the Aerostat out there, fly it at night, and watch that for them, and it's amazing the detail from the IR camera. You can see the level of the fluids in the tanks. So it actually wasn't something that we had ever imagined using it for, but it actually worked out very well. And the second, the bottom picture there is something that just happened last year as a result of Hurricane Harvey. We had a customer where they had several of their tanks where the floating roofs failed. And so they had a lot of these tanks where they had product and water on top of the floating roofs that needed to be pumped off. And so we took the Aerostat and we gave them an eye in the sky, so to speak, so that they could make sure that the operation went off without any issues. So again, something I never imagined we'd use this tool for, but it actually worked very well for that application. All right, so I'm getting close to the end here real quick. We're going to talk about some other opportunities that we're also looking at for this equipment. One of the things I think might really work well is to take this use it for forest fires, fire mapping, marking hot spots and so forth with the aerial platform. And then, as you can see, flood contamination, surveillance, pipeline leaks, storm surge, and oil seep monitoring. So I think that, again, outside of what we originally intended to use it for, we're just looking for oil on water during an actual emergency response. So, and then I will close with a little training evolution that we did in May, and decided to see what we could see if we flew over the lava flows from the volcano out in Hawaii. And it was really a unique opportunity, and we flew with the TRAX system, and The left-hand picture is the multispectral camera, and it really didn't give us a lot of good detail because we were looking through some soot and smoke that came from the volcano, so we really didn't have a good visual look at it. But the IR, I think, imagery is what really kind of surprised us, in that it did see through that the smoke and soot and gave us a very good detailed depiction of where that lava flow was. So very interesting, and all really cool stuff. So again, thank you. I just wanted to pass, this was our a practical use of the science that you're all talking about today, and thank you for the opportunity.
Thank you.